Today we are going to talk about AI agent. What is AI agent? AI agent is a program or a system that is based on LLM that will interact with your system or API and perform actions accordingly. So the question arises, if they are based on LLMs, then how they are better than LLMs? Biggest issue with LLMs are they cannot connect with your database, your APIs or your file system. Whereas in AI agents, we are creating a wrapper around it so that it should be able to interact with APIs, your databases, or call any function that you want. So they overcome biggest challenge that LLM has. That LLM can only provide information on the basis of data they are trained on. Whereas when we provide them with a wrapper, that they can access the entire system or even internet if you provide access accordingly. AI agent takes input from user, convert it into appropriate action, and then provide that appropriate action to a Python or any programming language wrapper that will then perform the action and return the result. That's how AI agent works. So this action and result works in loop till we get the final result. Now to get AI agent or LLM work how we want it to be, we create a system prompt. This system prompt interact with LLM model and then it will tell it like how it needs to perform the action, like how the action should be, how it needs to be planned, how it needs to be executed, or how the result should be created. This system prompt contains three different things. One is steps, how model is going to take actions. So these steps needs to be in a fashion that programming language can understand, because it needs to call the function when LLM asks it. We need to provide the LLM model with the resources like the functions, APIs, and whatever it needs to perform. Like if for example, if we consider we want to get latest running status of a train, in that scenario we need to have a function that is going to call your API to get the status and then return it to the LLM model. So that is a resource. And also we will have to give it an example like how we are going to think. For example, if we need to have a temperature or weather of a city, then for that city we need to first plan like, okay, we have to call a function, get the result, and then analyze it and provide an appropriate result to the user. So that's how the example will be. Let's consider this example where the Python middleware is there. So the prompt is get train running status for train. So for this, there is a reason plan. So basically LLM model is thinking to itself that for getting the status for this train number, it needs to call get train status for this parameter. Then it is going to call the next invoke action step that will pass this function and input to the Python program. Now this Python program will parse this JSON object, it will get the function name and input and then call this function and return the result. So this result is then returned to the LLM model where it is going to analyze it and provide appropriate result, like the train is delayed in New Delhi by 10 minutes. So this is where the Python middleware is taking care of calling the function and returning the result. So LLM directly cannot call the function, whereas it is asking us to call it, and this Python middleware is handling all these requests. Let's see this example in detail. That is get train running status for 12672. So this is the entire flow that we are going to traverse along with the LLM model and the Python middleware. So our input is going to be get train running status for 12627. Now this is our system prompt, like follow the primer steps. These are the steps, these are the functions, or these are the resources available to the LLM, and example how it needs to perform this action. So LLM model will get input along with the system prompt. It is going to return you, that is the reason plan. So this is just a plan that it is going to call this get train status for 14628 or 682. It is going to have the reason plan. So our switch case is going to handle it and it is going to consider this as a reason plan. So what we will do, we are going to append this message with provide invoke action. So this was a plan. Now we need to have an action to actually call the function. So we are going to append it to the message and then again go back to LLM specifying, okay, now everything is fine, this plan looks good, we need to provide the action, or we need to have an action to actually call the function. So now if you see here, we got output as invoke action function. So if you see this is JSON, it is type invoke action, on the basis of which we are going to call the switch. Then we are going to get invoke action, it's a function. function is this get train status. So we know what is the function and what input is going to get passed to this function to get the actual result. So this function calling will be handled by us. Our middleware is going to call this function, invoke basically this invoke action, and it is going to call this function and append the result along with the message back to LLM. So something like this. So if you see here, role developer content, so this is us or our middleware that is saying that this is the result, and then the output will be passed to this message. Now the LLM has the result of this function. So now it can go through it and understand what is the result, something like this, and it is going to return you explain output. So this is the explain output step, which is another switch case on the basis of type, where you can see output is the Karnataka Express train number is currently departed from Bangalore city. So basically it is understanding the JSON that we return from this function, it is parsing it, and then it is going to return you this. So this is final output is going to be something like this, and this is how our flow is going to get ended. For detail, we have already created a video on this where we are also calling something like a Karnataka Express, where we are not passing the number but the name, and we have given a function that gives mapping of train name with train number, and then LLM is capable of understanding that it needs to call the mapping function first in order to get the number and then call this function. If you like this video, please do like, share and subscribe. Thanks for watching. Bye.